Hey there, it's Alana Tucky, and I'm here to help you with more statistics problems. This time we're tackling 10.2, number 35 from the study plan. And again, where that might be in your homework or quizzes, I don't know, but here we go. So for every football game, there is a team that is expected to win by a certain number of points. In betting parlance, this is called the spread. If point spreads are accurate, we would expect about half of all the games played to result in the favored team winning, which is called beating the spread. About half of all games to result in the favored team not beating the spread, right? Not winning. The accompanying data set represents the results of 45 randomly selected games where a 0 indicates that the favored team did not beat the spread and a 1 indicates the favored team did beat the spread. This is actually pretty common to do with something like this, which is actually a qualitative thing. So yes, I won, no, I didn't win. Yes, the team won, no, it didn't win. To represent the words yes and no, we use 1 for yes, 0 for no. They'll do that sometimes with male and female as well. Right? Anyway, so did the data suggest that the sports book establish accurate spreads? Click the icon to view the results. Okay, so if I click here, I can see, lost 1, 1, 1, lost 1, 1, 1, etc., etc. Now I can copy this. I'm actually going to copy it to a clipboard. That's just the way I prefer to do it. You can open it in StatCrunch as well, but I already have StatCrunch open and I didn't want to fight with the windows. Anyway, all right, so this is wins or loss, win. Okay, and then I'm just going to be lame and copy all of that into my StatCrunch, which I actually have open in a different tab here. There we go. Let me make that bigger. Hold on one sec. There we go. Now we've got it. Okay. So we got our losses and our wins right here. Now what do they want us to do? Let me go back. Let's see. Okay, so first thing, since the sample is random, check the conditions that make it so that you can conduct a hypothesis test. Well, certainly, however many of these games, 45 games, well, that's less than 5%. That leaves us with the other big kahuna, which is to make sure that it's normal. Now, this is kind of strange because they have this out of order, but your null and alternative hypotheses are going to be 50% because it says right here, half of all games, right? So you expect half of all games, that's 50%. 50% is half. Let me go type that into Excel. That way we can get our ducks in a row here. So hold on one second. Oops. All right. Sorry, I had to pause you there. But anyway, so the null is going to be, that's 0.5. The alternative is going to be not 0.5, right? We know that n was that there were 45 games. And again, we know that p is hypothetically speaking 0.50. As a matter of fact, I'll call it p underscore 0, just so I can keep it straight. All right, so we're going to check normal here. I can do it with, I'm making it bigger so you guys can see, but I could do this with a calculator just as easily as Excel. I'm just using Excel because I have it. So this times parentheses 1 minus that. There we go. That's 11.25. This is greater than 10, so normal. And the independence thing, you can kind of wave your hands, but independence, 45 is certainly less than 5% of capital N, whatever capital N might be. I mean, we're talking about all the football games ever, I mean, it's just ridiculous. So even if you're just talking about a particular year, it doesn't matter. So, because this is all the football games, it's not just, one game or one team, it's all of them. So, all right, so we've got our normal, we've got our independence, and then, which is all they're saying here. It's like, sure, this is less than 5%, no problem. So reasonable, etc., etc. All right, so then the null and alternative, and again, I think that's a little bit backwards, but whatever, I mean, technically you sort of need to know your null and alternative are 0.5 before you ever figure it out up here. So it's kind of screwy, but hey. And then they come up with a p-value, which we are going to come up with in a second. Now, the easier place to get that from is from StatCrunch. I'm just using Excel as a glorified typing and calculator here. So none of that stuff was magical. All right, so let me go to Stat. and I'm going to go to proportions, one sample, and now this is what's rare. We haven't really had a lot of this, but this is one that we actually are going to use data for, not summary. We weren't given a summary. We don't know what proportion of these are zeros and ones. So we actually have the raw data here, which is quite rare in this text. You know, it's pretty common in higher level text, but it's not a pretty common thing for low level stuff. So, all right, and then we want success. We're going to count as 1. Right? The 1 was the success when they actually did beat the spread. Let's say next. My hypothesis is 0.5, so that's good. My alternative is not equal because I don't really care how it doesn't make the spread. It just has to not make it. I believe that was, do the data suggest that the sports book establish accurate spreads? Accurate means both directions, right? So you want this to be accurate. Let me put it this way. You do not want it to be inaccurate in either direction. You don't want it to be too low. You don't want it to be too high. If a spread is accurate, then the winning team's going to win about 50% of the time. It's not going to win over 50%. It's not going to win under 50%. It's going to be around 50%. All right, so let's see, go back, which I kind of already assumed anyway in order to make it not equal. Oops, there's my Java. Okay, so not equal, next. I don't need to store it. It's fine. Calculate. And there it is. I have a really high p-value of 0.6547, which is crazy high. So let me paste that into my lovely Excel spreadsheet. There it is. I love that about Excel because it's not as nice for this upper level calculation stuff, but it's still nice for putting everything in and trying to organize it. It saves a lot easier than a web program like StatCrunch would save. All right, so you can see that that sample had 53% of them are ones, right? So if you counted the number of ones divided by the total of 45, there were 24 ones in there out of 45, that gave us 53%. The standard error, which is that big honkin' square root of, what is it, p hat, or p0 times 1 minus p0 over n, that one. That's what this guy right here is. And that's your test statistic, if you want to call it that. Okay, if you were doing the classical method, that would be really important to you. It matters for p-value method as well, but it's not quite as big of a deal. And the p-value is 0.6547, which is crazy high. We are not going to reject the null hypothesis, right? Right? The p-value is huge. And it's higher than whatever the heck alpha was. So I don't know what alpha was, but whatever it is, it wasn't that big. I mean, we generally talk about alphas being like 0.05 or 0.1, and 0.6547 is much higher than that. And remember, we only reject when something rare happens, when it's so unusual that it's like, oh, no, the spread was off, right? But this wasn't unusual at all. Getting 53% is totally normal. Right. Now, if you're on an exam, you might be asked to draw a picture. So let me go grab Minitab for a second. Actually, I might be able to do it with StatCrunch. Let me see here. If I go to Stat Calculators, and of course you would do this by hand. You don't need to do it this way. But all right. So our mean was 0.5. Our standard deviation was, where was it? 0.0745. Okay. And again, you wouldn't necessarily know that. You would just kind of draw a basic curve. That's fine. Oh, no, we're doing z-scores. Sorry, I'm losing my mind. 0, 1, fine. Okay, so then we had our z-score, which was 0.447. 0.447. So 0.447. That's the beautiful thing about it, is if you find z-scores, then it's always 0 and 1. 0 and 1. I'm sorry, I was losing my brain slightly. So, because we're looking at z-scores. Z-scores always have 0 for the mean, 1 for the standard deviation. So there's my z-score of 0.447. That's my test statistic. So if you're asked on an exam to draw a picture, you literally draw a normal curve. You put 0.447 down, which everybody should know where that falls, about there. And then you shade all of this to the left, and then you would label it as 0.67 for its area. Right? And of course, on a final exam, chances are I'm not actually going to make you do that. Hold on. Let me get this picture. Hold on. There we go. Got it right here. And then I'm going to copy, and then I'm going to take it back to Excel. All right, so like I was saying, on an exam, a lot of the time, you don't really have the time or the energy or the calculator or the computer to be able to calculate the p-value. But I totally give this output. I'll give you this output and I'll ask you all sorts of questions like, what was the sample proportion? What was X? Heck, if I didn't give you p hat, if that was missing, you could still find it yourself, right? With a simple calculation of 24 divided by 45, right? So, and then I could still, and I usually do ask for drawings like this, right? So you don't have to do the calculation. It's already done for you. It's sitting there in the output. So it's 0.65, but you have to label like that's 0.447 where that boundary line is. And then that red area that you shade is 0.6547, stuff like that. Okay, so let's see if that matches up with what they said. 655, right? So if you round, that's good. That's p-value. And so they said, do not reject the null hypothesis because your p-value is too high. Great. So that means that, I better do the conclusion. So when we do not reject the null hypothesis, that means that there is not enough evidence to support the claim. And the claim is always the alternative hypotheses, that the point spread was not, or inaccurate, let's put that word. Right? So even though we weren't 0.5, we were close enough, right? I mean, you expect it to be a little bit of give and take, and that 0.533 is well within the give and take. And that's what the 0.074 is. That 0.074 is that give and take. What's your wiggle room? What do you expect for plus and minus? So we expect plus or minus 0.07 for a standard error, and we are well within that. So this is not rare. We are not going to reject the null hypothesis. All right, I hope that helps with that one. See you back here for more.